James is my student number here as well, and this is a video of the task for filters that we've been taking out for the last couple of months.
Hi, I'm Trevor James and I'm participant 2 within group number 8.
Here we've got a video of our breadboard with all of the filters we've used throughout this project. We have, if we start off going from left to right, we start off with the low filter just here. We have the capacitor values and a circuit diagram down the bottom. And then next along we've got the high pass filter, and we've got a circuit diagram here as well. This one's in blue because if you put them both in series, or cascaded, just like this one here, you actually have them together and this creates a band pass of the desired frequency range that we want, which is 3 kHz to 3.5 kHz in this case. And then the output for this is quite heavily attenuated, so we do have that problem. This can be improved by if we have a buffer, which we have here, which is just a 741 op amp, and here is the circuit diagram of the breadboard just up here. And then on the right, we'll go to Trevor for...
So this is our 20-notch filter, and this allows us to have a specific frequency cutoff. It looks a little complicated, but ideally we have 2 resistors to give us a closer value. Cheers, James. 2 resistors which are equal to 1 resistor. This is duplicated on either side. We either have this resistor is generally equal to half of this value, and we have 2 capacitors and our capacitor which is the same as these values, but together in parallel it's equal to double that. We've utilised a Fourier transform with the FFT function within the oscilloscope in order to see the frequency spectrum of the input. As you can see, the peak will go past the center of the screen shortly and be attenuated around this frequency and go back up. And this is around 3.25 kilohertz.
This is a video of our wave and time base. As you can see, the red wave is the circuit and it will completely go down to almost horizontal at about 3 kilohertz.
And this is it rising back up. The transfer functions with you today, Jamal and Luke. So we start off with our low pass and our high pass, and we look at the Laplace domain of the resistor and capacitor. By using a potential divider, we can go through and work out the transfer function for each low pass and high pass, which we come out as 1 over RC, S plus 1 over RC, and for the high pass we have S over S plus 1 over RC. In order to get a band pass filter, we can multiply these 2 transfer functions, which I'll get James to do within MATLAB.
MATLAB that we've used for this project just to simulate the transfer functions that we've achieved by actually doing some calculations. As you can see, we've got the capacitance, the high pass filter capacitor up here, then we've got the low pass value here as well, and then we've got the value for the low and high pass resistors, and then we also have the actual transfer functions of the combined band pass filter, the high pass filter, and the low pass filter. Sorry. And from that, we have generated this one on the left here. This is the transfer function we have actually acquired, and just to validate this and actually check it, we've also put numbers in on a website we have found with the same resistor values and capacitor values, and it's generated this one, and as you can see they are very similar, so just proves that it's actually right.